We know how React manages state, or at least we have an idea, but there's one thing which is important, which I mentioned before, but which I now want to emphasize again, and that is how React handles state updates. In your code, you might have a component, and in that component, you might manage some state with help of the useState hook. And therefore, React in the end manages that state for you. Let's say the initial state for this product component is DVD. So we have a DVD as a product here. Now, eventually, because a user clicked a button or whatever, in that component, we update that state. For example, with setNewProduct, that could be our state updating function returned by the useState hook. And we set the new product to book. So from DVD to book. Now what happens with that is not that DVD is instantly, after setNewProduct finishes execution, is replaced. DVD is not instantly replaced just because setNewProduct is done running. Instead, calling setNewProduct and calling those state updating functions in general schedules a state update with the data book. But that's now a scheduled state change. React is aware of it. React plans on processing it. React doesn't process it immediately though. Now, in reality, most of the time, state changes, scheduled state changes, will be processed very fast, pretty much instantly. So in reality, it might feel instant. If we click a button and that removes a paragraph, to us as a human, that happens instantly. But React reserves the right of actually postponing that state change. For example, because a lot of other performance-intensive tasks are going on at the same moment, potentially tasks that React considers to have a higher priority. Let's say on your screen you have an input field where the user is able to type something. Reacting to that user input would have a higher priority than changing some text on the screen. And for reasons like that, React might postpone scheduled state changes. Now, what React does is it guarantees you that the order of state changes for one and the same type of state is guaranteed. So if we call setNewProduct again and we set this to, let's say, carpet or whatever, then this state change would not be performed before the previous state change. So the order is kept, but it's not necessarily executed immediately. Eventually, of course, it will be processed and your new state will be book. And once that new state is active, once that state change was processed, React will reevaluate the component, it will rerun the component function. Now, because of that scheduling, where of course you might have multiple outstanding scheduled state changes at the same time, because of that, because multiple updates can be scheduled at the same time, because of that, it is recommended that you use this function form for updating your state if you depend on the previous state snapshot. In a lot of cases, this will probably not matter because it's processed so quickly that you can't even click fast enough to see a delay. But because it theoretically could be postponed, this is the safe way of ensuring that state changes are processed in order, and for every state change where you depend on the previous state, you get the latest state. Otherwise, you might just get the latest state when the component function was executed last, which is not necessarily the same state as if the state changes are executed in order. Because if you have multiple outstanding state changes, they all come from the same last re-render cycle of that app component. They all come from that last component snapshot. But of course, if they were processed, the component would re-render in between, but since they're all already scheduled, all outstanding states changes don't take that new in-between component result into account. That's why this function form is helpful, because there, React will actually ensure that for every outstanding state change, it looks into the latest state and gives you that, and does not use the latest state from the last time the component was re-rendered. That's an important difference between when the component was re-rendered and when a state change was scheduled. You can have multiple outstanding state changes from one and the same component re-evaluation. That's the key takeaway here, and that's why this matters. That's also why in the last non-project module, where we initially learned about useEffect and so on, it was safe to actually update our form validity based on the email and password is valid states inside of useEffect. Because just like using the function form for updating a state based on a previous state snapshot, useEffect actually, because of its dependency mechanism, is ensured to rerun the effect here every time a state or a value, which is a dependency, changed. And therefore you can't miss outstanding state changes, because here it will simply rerun this effect for every time the component was re-executed, the component function was re-executed. It will thereafter always rerun the effect, and therefore you are also guaranteed to get the latest state when doing it like this. So these are simply two different patterns for dealing with one and the same problem, you could say, depending on what you're trying to achieve. Here we want a state update that depends on some other states. In this case, on the other hand, we want a state update that depends on the same state, just a previous snapshot of that state. So that state update scheduling is a mechanism you have to keep in mind. Not because you actively need to do something about that. React manages those scheduled updates for you, but because you need to write your code accordingly to rule out any danger of potentially working with outdated data. You rule it out when using that, you rule it out when working with useEffect. Now there is another important thing you need to know about state in React. There we actually have this nav context, and in the navigate handler I do something which you see a couple of times throughout this course. I call two state updating functions after each other. Now we just learned that just because you call such a function does not mean that in the very next line the state was updated. State was not updated here. Instead, we just learned that the update will be scheduled and eventually the entire component will rerun, so this component in this case, and then once this component reran, then we have the latest state available, not earlier. Now that's what we learned. Now here, however, we have two state updating functions after each other. That clearly means that two state updates will be scheduled. Does this, however, also mean that the component will be re-executed, re-evaluated twice? You could imagine that this happens, but that's actually not what React does here. Instead, if you have two state updates in the same synchronous code snippet after each other, so not in a promise in different then blocks, but in the same function, for example, where nothing in between would cause a time delay or anything like that. So if you have two synchronous lines of code after each other, where you then call a state updating function, in such cases, React will batch those state updates together. In one long synchronous process, so for example in one function that executes start to end without any callbacks or promises in between, in such cases React will take all the state updates that are produced by that function and it will batch them together into one state update. So back in this picture, even if we would not just update the new product here, but if we would update something totally different in the same function, we would still just have one scheduled state change, which then, however, just changes two different states. But it's one process. It's not two scheduled changes with two upcoming component re-executions, re-evaluations, but instead it's one scheduled change where all the different states you might want to affect are simply batched together. So state batching is another important concept you have to be aware of when working with React.